What's up, guys? It's Quadrifter, as the bottom right hand corner of my screen would indicate. I've decided to do some instructional videos and some how-to videos. This is more of an informational video and an introductory to electricity, or at least how I understand electricity, and I've related it to two different ways that might make it easier for the majority of people to understand, because there seems to be a lot of confusion on it. First off, there's two different kinds of electricity that you've seen. There's alternating current, which alternates back and forth, at least in the US, 60 times per second. It can be transmitted over long distances through thinner wires rather than using DC, and it's cost effective to do that way. Having said that, 95% of everything in your house uses direct current. LED televisions, computers, your phone, cameras, everything. There's very few appliances that actually run off of alternating current. Now, I was taught electricity using a water method, where voltage is the pressure, amperage is the current, and it's simple, but there's other ways of explaining it, and I don't know if very many people have ever thought about it, but the main thing you need to take away from this is that volts push amps through ohms to make watts. Have your voltage. Voltage can be thought of as octane of gasoline. So you've got 89, I think it's 90, and then there's one more grade, 98 or 93. I believe it's 93. But anyway, the octane is how flammable the gas is, pretty much. So the more flammable, the bigger explosion, the harder it's going to propel your vehicle. So that's pretty much the power of your gasoline. The voltage is the strength of the current. You can think of amperage as your fuel. You've got 2200 milliamp hours over here in this battery. You've got 22 gallons of fuel here. This octane of the gas the fuel has a rating of 89 octane. That's pretty standard for vehicles. 5 volts, that will run small LEDs no problem. Just a simple comparison. As this battery uses energy, the electrons will go from the negative terminal, they'll flow along the wire, they will hit the negative terminal of the LED, they will hit the positive terminal on the other side, and then they'll go back to the positive terminal of the battery. That will make this light shine. The wire, that is the resistance. Anything you pump electricity through has resistance. I'm not going to go into resistance factors or anything like that. You just simply need to know that whatever you're going through has some kind of resistance. Now, that is where the water thing comes in, and it's real easy to understand. If you try to walk through a room, it's usually pretty easy, provided there's nobody in your way. If you're in a pool and you try to walk through the pool, there's resistance of the water. That's the easiest comparison I can think of there. But for this example, you have the resistance of the road. So as your engine uses the fuel, the resistance of the road is what you're trying to fight against. Well, the same thing with your battery. The voltage is trying to push through all this wire. Now, the longer lengths of wire you use and the thicker lengths of wire you use, there's voltage losses, but you typically don't really have to worry about that if you're building small electronic devices, which is where most of this information is going to be beneficial to the majority of you. Now, the watts, that is the power produced. So, you could think of, you get 20 miles per gallon as your power rating, or you can think of it as horsepower if you want to. Horsepower would probably be a better example, but if you get 20 miles per gallon, that's pretty much for the whole tank. If you have a vehicle that's putting out 300 horses, then you can think of it like that. But the amount of wattage that comes out, that's produced from whatever you're trying to power, be it an LED, a brushless motor, anything, there's always some kind of wattage produced. And that is just your power. I will go into the calculation in a minute. I'm going to give you one other example of how to explain this. Here you see we have the same thing. There's our battery. It's a 2200 milliamp hour battery. And over here, for you video game nerds, I was thinking about this, you can compare the voltage of a battery to the strength of your character in like an RPG. You can compare the milliamp hours or the amperage to the stamina. When you're swinging a sword in the game, if you have 100 strength and your stamina is at 2200, every time you swing it's going to knock your stamina down some until you basically can't swing anymore, or your strength gets taken down because you can swing the sword but you're not very effective. The resistance, or the ohms, can be explained by the enemy armor rating. So whatever they're wearing, leather, iron, whatever they want to, crazy armor they want to wear or call it in the game, the resistance can be explained like that, and the damage inflicted would be your wattage. And I forgot to explain that when you do power a device, there is a rate at which it uses power. So let's just say, for example, this is pretty standard. 5 volt, 2200 milliamp hour battery powers a 5 volt LED. The LED will use 25 milliamps. So basically, you can do an equation and find out how long that battery would last under that load, theoretically. Now, there's all kinds of outside factors, or even inside factors. I mean, there's temperature, there's internal resistance of the battery, but that starts getting into really complicated, and we're just doing a simple LED. It's probably going to be pretty right on. Basically, you take your voltage, which is 5, and then you multiply that by the amperage. Now, don't multiply it by the milliamperage. You have to convert the milliamperage to just amps. So you want to take 2200 and divide it by 1000. So 2200 divided by 1000 is 2.2 amps. So that's a 2.2 amp hour battery. So you take 2.2 amps and you multiply it times 5. That is 11 watts right there. Now what we're consuming is 5. Well, first, do this the easy way. We'll 25 divided by 1000. 0.025. Multiply that by 5 volts, and you're not even producing a whole watt of power. So you're barely using anything out of this battery. If you want to find out how long this battery will last under this load, you can basically do 25 divided by 2200. I'm sorry, 2200 divided by 25. And theoretically, this small LED on a 2200 milliamp hour 5 volt battery could last 88 hours. Now that is completely theoretical. Again, there's outside factors and internal factors that could possibly have an effect on what you're trying to do. But it's the simplest way that I can explain things. Just remember, and this is what you need to take away from this little bit of information, is volts push amps through ohms to make watts. So remember, your strength pushes your amps through the ohms to make watts, and that is, watts is always the power released. At least that's the best way I can explain it. There's another example of, you got a bag of water and a bag of water. The one bag has a 10-pound weight on top of it, and this one has a 20-pound weight on top of it. Now, when you poke a hole in this one, that's your amperage, is the current. It's not very much because it's got a 10-pound weight on it, but the 20-pound weight one, the stream will go further. So that's pretty much how hard it's pushing the amperage through the battery. That's pretty easy to understand, but when you start relating it to things that you deal with more, like a vehicle or video games, to me it seems a little easier. But anyway, that's my first instructional video. If you have any comments or anything, leave them in the comment section, because that's what it's for. Like the video, subscribe, share, the usual. Thank you for watching, and subscribe for more videos. Bye.